variables. We have two learning targets. The first is to calculate the mean and standard deviation of the sum or difference of random variables, and then to find probabilities involving that sum or difference when you have independent normal random variables. So our context that we've been using for the last few days is this idea about if you had a job where your wage was randomly assigned in some way. So this is actually our third day in this context. And so after thinking about it, I finally have decided on a permanent employee wage system. And what I'm going to do is I'm going to randomly assign using the probability distribution X that's given below. So this first table we have here, this is my probability distribution X. And so that's how I am going to randomly assign hourly wages. But then at the end of every year, I'm going to give my employees an hourly raise or a bonus, in other words. So those bonuses are also assigned randomly, and those bonuses are given down here. And then we are going to assume that those are independent. So whether or not you are $9, $12, $15 an hour, your likelihood of getting a $1 raise or a $3 raise, that is still the same. So those are independent distributions. All right, so what I would like for you to do is to work through questions 1 through 3B, actually. So I'm going to have you stop right here so we can check and make sure everything looks good before you move on. Everything in this first portion should be something that you can do based on the previous days or on previous lessons. So if you need to, you may want to look at your notes from those days to help you figure out how to solve these questions. All right, so take a little time and do that, and then we'll go through our answers. Let's get started with question number 1. So with distribution X, we've been asked to find the mean, variance, and standard deviation. The mean and standard deviation, we've been talking about that for a couple of days. You could do that in your calculator using your list functions, or you could go ahead and do that by hand. With this, the mean is $11.85. Standard deviation is $2.22. And you may recall from 2 lessons ago that we talked about how variance is the square of the standard deviation. So if you take 2.22 and square it, you get 4.93 as your variance. Then I did the same thing for distribution Y. So I have a mean of $1.60, variance of 0.839, so about 84 cents, and a standard deviation of about 92 cents or so. Okay, so then we are asked to think about this new hourly wage for the next year. So let's think about first, like, what are all the different possible hourly wages that my employees could get? Well, let's start with the person who earns $9 an hour. That person who earns $9 an hour, what could they earn next year? Well, they either get a $1 raise, which would put them at $10 an hour, or they get a $3 raise, which would put them at $12 an hour. And then I just kept going through that process. So I thought about, okay, what about my $12 an hour person? How much could they make next year? Well, they either get a $1 raise, which puts them at 13, or a $3 raise, which puts them at 15. And then I continued through. So next we are asked, though, what is the probability of an employee being assigned $9 an hour and getting a $1 raise? Well, that and part, you might remember back to our previous lessons when we were talking about probability, when we talked about or problems or and problems. And when we talked about and problems, we talked about them as multiplication. Now, in this case, we know these events are independent, so I don't have to worry about one probability changing. So what that means is to find the probability of 9 and a $1 raise. Well, I'm just going to do the probability of $9 an hour, which we know was 30% or 0.3 from up here. and they get a dollar raise. So I'm going to multiply that by the probability they get a dollar raise, which was 0.7. So I get a probability of somebody getting $9 and a dollar raise is 0.21. So what I want to do now is in this table below, and see it says complete the table below for the probability distribution of N, meaning their new hourly rate for the upcoming year. So I'm going to take all these values from there, and I'm going to fill in my table. So they could either earn $10, $12, $13, $15, $16, or $18. And now I need to find the probability that any of those wages occur. Well, I already have the first one. 0.21 is the probability of getting $10 an hour next year, because that's $9 and $1. So what I'd like you to do is to then go through, and you need to finish up the rest of this table. So you've got to find all those probabilities. Once you've done that, then just like we did on our previous ones, I'd like you to find the mean, variance, and standard deviation. And then my goal, the big goal for today, is to figure out, okay, once I have this new distribution or these combined random variables, try to generalize to figure out, okay, what is the new mean and what is the new standard deviation? Where did those come from? Okay, so take some time to work through this, find all your probabilities, find your mean, variance, standard deviation, and then try to generalize. Okay, so if you could double check your table with mine and all of your probabilities. So I went through that same process I did in part B, where I was multiplying the probabilities together and filled in my whole table. And then to find the mean, variance, and standard deviation, you could use whatever process you had used up above. I did mine in my lists in my calculator, and I found a mean of 13.45. So I'm going to start with that for now, and I'm going to think about, okay, well, this new mean, so N is this distribution. So the mean of that new distribution, or mean sub N, or mu sub N, is coming from X plus Y together. So I'm taking these two distributions and I am adding them. Okay, well, where could this new mean have come from, this 13.45? And I'm thinking, well, if I'm adding two distributions together, what's going to happen with the means? Well, I notice up here I had this first mean is 11.85. My second mean is 1.60. And I can go ahead and double check this in my calculator, but I'm pretty sure that equals 13.45. So I'm going to write here, this is 11.85 plus $1.60. And that gives me $13.45, which makes complete sense. If I've got this first distribution where the average that they make is $11.85, and then the following year I'm giving out raises with an average of $1.60, it makes sense that the new mean should be those added together. So my notation down here, mu sub N, is coming from, well, it was the mean of the first distribution, which we said was mean of X. So my symbol here, I'm going to do mu of X plus mu sub Y, so of my second distribution. Okay, seems pretty reasonable to me. So let's check standard deviation and see if that same thing happened. So my standard deviation up here was $2.22 plus 91 cents about, or 92 cents. So down here, $2.22 plus 0.917, that does not equal $2.40. So for my standard deviation, I can't simply add those together. Well, I was asked a lot here about the variance. Variance isn't something we talk about a lot, so it's kind of making me think like, well, why is variance on here? So I'm going to look at the variance. And so my new variance is $5.76. Could that be coming from $4.93 plus 0.839? Yes, that equals 576. So what I'm realizing here is while I cannot add my standard deviations together, I can add the variance. So what I'm going to write underneath this is I'm going to say can add. Under standard deviation, I'm writing you can't add that in. Okay, so you are never allowed to simply add standard deviations. What you can do is you can square them to turn them into variance, add them together. Well, that's going to give me a new variance. How do I turn that variance back into a standard deviation? I'd have to square root it. So what I'm going to do down here is I'm going to put, so this is my first standard deviation. So the standard deviation of X. Well, I have to square that to turn it into a variance. Then I have my standard deviation from Y, square that to make it a variance. And now I am allowed to add them together. However, again, that is not a standard deviation right now. That is my new variance. So to turn it back into a standard deviation, I have to square root. Okay, so let's go on to our important ideas. Got quite a bit we want to fill in here. So first of all, we've got our rules for when you're adding and subtracting random variables. So we talked about combining them. For combining, we're always either going to be adding or subtracting. So adding and subtracting random variables. And I'm going to call those random variables X and Y, just like we did on the front page. Okay, so we only looked at on the front page what happens when you add your distributions together, or add your random variables. So I'm going to start with that. So if you are adding them, your new mean for X plus Y when it's added together is going to be mu sub X plus mu sub Y. And now to find my standard deviation of those added together, I need to add my variance. So I've got my variance of X plus my variance of Y, and then to turn it into a standard deviation, I'm going to square root. Okay, now that is for addition. We also could have subtracted those. So mu of X minus Y is mu sub X minus mu sub Y. No surprise there. Now, this next part gets a little bit tricky. So with your standard deviation, for X minus Y, well, remember when we're thinking about standard deviation, we're thinking about how spread out a distribution is. So if I'm taking two distributions and I am adding them together, I am increasing the spread, or I'm increasing the variability, which is why when we're adding them, well, of course, we add them together. So you're imagining you've got like one distribution, another distribution, you add them together. Well, what if instead I subtracted these distributions? So now instead of me just putting them together, I take one minus the other. So kind of thinking of it like this, like it's just flipping sides. Well, it's still going to become more variable. If you're taking two distributions and combining them, they're always going to become more variable. So the good news is it's our same formula. The bad news is it's a little tricky to remember. The most common mistake people do here is they subtract their variance. Even when you are subtracting random variables, you still add the variance. So I am still going to take my variance of X and I am still adding it to my variance of Y and then square root to turn it back into a standard deviation. This is the most common mistake probably in this whole chapter, is students will accidentally subtract those variants instead. So I'm going to add a note down here. Be careful. Always add variance. We do not subtract it when we're combining random variables. Okay. And then now that we know how to combine random variables, we could also combine normal probability distribution. So we've been working again with normal distributions. So if you are asked to combine normal distributions and then calculate a probability, the only thing that is changing here is that you need to find your new mean using the rules we just talked about. So find your new mean and your new standard deviation. Once you've done that, then you go ahead and just do a normal calculation like we've been doing all year. All right, so please take some time to read through the Check Your Understanding problem and then work through that. Hit pause as you go through it all, and then when you're all set, hit play and we'll go over the answers.
All right, so let's go through our answer. So I started here by color coding. So everything for the number of diapers changed for Elise is in red, and then the number of diapers changed for Jocelyn is in green. And then the total, x plus y, I'm going to add those together. So t equals x plus y. So for part A, we are trying to find the mean of the total, or mu of t. So you can see here, I'm just adding up those two averages, or the two means. So mu of x plus mu of y, added those together, and I got 9.65. So that is the total number of diapers on average that we're using. So for my interpretation, I want to add in, though, that since this is a probability distribution, this is after many, many days, or many, many randomly selected days. So for my interpretation, I have that if we take many, many randomly sampled days, the average total number of diapers used is about 9.65. So I've got that many, many in there, and then also that it's an average and it's an approximation, or an estimate, I should say. It's about 9.65 diapers per day. Okay, and then in part B, we're finding the standard deviation for the total. Now remember, we cannot simply add our standard deviations. You add your variance. So what I have here is my standard deviation for Elise, and then my standard deviation for Jocelyn. I squared them both to turn them into a variance, add them together, and then square root to turn back into a standard deviation, and I get 1.038. And that is the total number of diapers used each day, typically varies by about 1.038 diapers from the mean. So this is the same interpretation of standard deviation that we've used all along. It's the blank typically varies by blank from the mean. What's different in this case is that first spot, the what is varying. Well, the what that's varying is the total number of diapers. So that amount is typically varying by about 1.038 diapers from the mean. And then now this last part, if I want to find the total cost, what I need to do here is I want to find the average cost and then the standard deviation of the cost. So we're going to start with Elise's diapers. So they're about 20.238 cents per diaper. So how much do her diapers cost? Well, her diapers, we need to figure out if she's using 4.75 diapers per day, and each one is $0.238, so 23.8 cents. To figure out the cost per day for her, well, I'm just multiplying that. And remember, multiplication does affect the mean. So I multiply those together. And then I do the same thing for Jocelyn. So her cost per day is $0.2975 times 4.9 diapers a day. And then since we're combining means, I'm just going to add those together, and I get a total of about $2.59 per day. Now with the standard deviation, it's a little bit trickier. I actually need to figure out first the cost and then worry about adding them together, just like I did with the means. But what's different, remember, I can't just add them up. I've got to square them first, add square root. So what I have here, same type of thing as I just did for the mean. I've got the cost times the standard deviation for Elise, because multiplication does affect standard deviation. And then the same thing for Jocelyn. And that would be the standard deviation of the cost for each one of them. And then to combine those, I'm going to square, add, and square root, and I get about 28 cents per day. That's the standard deviation of the total cost for the diapers.